Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest consecutive sequence problem, and this problem has been asked in Google, Microsoft, Facebook, Apple, Goldman Sachs, Uber, Twitter, ByteDance. So it's a lot of companies and a lot of huge ID companies that have asked this problem. So I'm going to pay my most attention. I hope you also do it. And I just have one request for all of you guys. Like my YouTube channel, if you see, most of the people, they are not even subscribed, and it takes a lot of time and a lot of effort to make these videos. So I would really appreciate if you can just subscribe. Like basically we are given an unsorted array of integer nums, and we need to return the length of longest consecutive elements inside the sequence. Also, there could be possible that there might be duplicates in our given unsorted array, so we just need to take care of those as well. And let's try to understand this with an example. So the example we are given over here is, and over here, if we find that what is the longest consecutive sequence we can find, the longest consecutive sequence we can make is 1, 2, 3, 4 amongst these values. And we can ignore just this 100 and 200 because there does not exist any consecutive sequence from those values. So over here, since we found 4 elements, we can return the length of this as 4, and this would be our answer. Same way, if we take another example, over here we are given 9 elements, and all 9 elements are actually part of the longest consecutive sequence. So in this scenario, we are going to return 9. So in the brute force approach, we are not going to do anything clever. We are just going to take the most basic approach that we can and try to find the longest consecutive subsequence. So suppose at any moment we are given an input like this, we are given an empty list. We can say that there exists 0 longest common subsequence elements, and suppose we are given an element like this, suppose this is 100, we can say that there exists exactly 1 longest common subsequence element in this given input. So that is a given, right? That even if with a single element, we can at least define that there exists 1 single longest common subsequence element. Now over here in this example, since we know that there are at least more than 0 elements in this given input, and initially we are at this 100th position, which means that we can say that the current longest consecutive subsequence we can find is 1. And now if we want to find a subsequence in the remaining group that consists this 100, how can we do it? Like, we can only do it in one scenario, that in this remaining portion, in this remaining elements, if there exists element 101, if this exists, we can say that 100 is also part of the or could be part of the longest consecutive subsequence. So this would be our basic approach, that at every single position we will try to find that whether the next elements could they be in the remaining input, and if they do, we will update our longest consecutive subsequence, and whatever the maximum value we find, we are going to return it as our answer. So we will also create another variable called current subsequence, and that would take care of what is the current subsequence that we are trying to find. Let's just name this current. Okay, and initially the current subsequence is also at also 1 over here at this 100th position. Now we'll try to see that whether this 101 exists in the remaining portion, and it does not exist, which means we will move forward. So we'll move forward with the element 4. Now for this element 4, we need to see that whether element 5 exists or not. So element 5 also does not exist, so we'll move on with just 200. For 200, we will see whether 201 exists. This also does not exist. For this one, we will try to see that whether 2 exists. So 2 exists in the remaining array. Now because 2 exists, the current subsequence we had was of value 1, we will update it to value 2. Now because this 2 exists, we can not break right now. We'll try to find more values. So we'll again try to see that whether 3 exists, and 3 also exists, which is over here. So again we will update this value to 3. Again, because 3 exists, we will try to see whether 4 exists. 4 also exists, and it is present over here. So we will update the current value of longest consecutive subsequence we have found to 4. Now we will try to see whether 5 exists. Now 5 does not exist, which means that 4 is the longest we have found so far, and then we will try to update the value of longest consecutive subsequence we have found. to whatever the current value is, because previous value of this was 1 and now this new value is 4. But we are not done yet. We have only checked up until this 1. So now we will check for this 2. So again for this 2 we will, and by the way, we will re-evaluate this value back to 1 because now we are starting with the new element. So again for this 2, 3 exists, so we will update the value to 2, and 4 also exists, so we will update the value to 3. But we cannot update the longest common subsequence because 4 is greater than 3. And now we again check for this value number 3. So for value number 3, 4 also exists, which means that this value would become 2 for this value number 3, but we won't update, and in the end we are going to return this 4. So this is our brute force approach. Like, this solution works, we get the desired answer. The thing is, we get the desired answer at a very bad cost. Like, even if we just try to calculate the time complexity, in this case the time complexity would actually be big O of n cube. Why n cube? Because we will need to iterate over every single elements at least once to find the longest common subsequence. So that is n amount of work. Then suppose over here we are initially at this position 100. So we wanted to check that whether 101 exists. So in order to do this check, we will also have to iterate over the entire loop. So then in that case, we will have to do n more work. And at any given moment, suppose over here we identify that for this 1, 2 also exists, right? And once we identify that 2 exists, we will again check whether 3 exists. Again we will check whether 4 exists. Again we will check whether 5 exists. So even to do these checks, we will have to do n more work. So again we will do n work. So in total we are going to do n times n times n, so n cube work to solve this brute force approach, and this is a very disastrous solution. Now, one better approach we can think of is, suppose that with the given input, if we do some sort of modification, can we come up with better solution in faster time complexity? Like, of course we can. So remember that what we are needed over here is that we need to find the longest consecutive subsequence of this given input. And we are going to see with this custom example how can we modify the input and how can we come closer to solution. So suppose in this given example, rather than keeping the input just like this, if we do sort the given input, things become much easier for us. And let's see that what would be the sorted result. Okay, so now we have our sorted result. Now in the sorted result, we simply need to find that what is the longest common subsequence that exists, longest consecutive subsequence that exists. And it's pretty simple to find now, because all we need to do is that at any point we know that the definition of common subsequence is that suppose we are currently at the value I, then I plus 1 would be a common subsequence, then I plus 2 would be a common subsequence, and this is the only condition we have to take care of. And the only other thing we need to worry about is having two duplicate values right next to each other. If at any point we encounter two duplicate values, we simply ignore one of those values and move forward. So in this example, we are only going to do two checks with the sorted input. First check we are going to do is, at first position we are going to check that whether this position is exactly same as whatever the previous position we had. If that is true, we would skip over because we don't need to do anything with that, because there are two same values. And if that is the case, so which is the case in this scenario, that both values are same, which means we would skip over. So we would go to the next element. And now we are at this next element. Again, we are going to check that the value we are currently at and the value before that, if they are same or not. So in this case, they are not same. If they are not the same, we are also going to check one more thing, that whether the current value of a of I. So suppose this 0 is actually a of I, and minus whatever the value of a of I minus 1. So a of I minus 1 in this case is minus 1. So if difference between these two values, if it becomes exactly 1, which means we can conclude that these two values are part of the longest common subsequence, and we could update their value. Again, like brute force, we are going to use two variables. One variable to keep track of longest common subsequence we have found so far, and second one is to keep track of the current subsequence that we are working on. So let's see that how it would work. And both the values would be set up as 1 initially. Now initially we are at this 0 and 1 pair, and because they are sorted, we know that they are always going to be adjacent to each other. So this is the only condition we need to worry once we identify that the both values are not same. So in this case we can say that the current subsequence we have found is actually size 2. So we can update the value over here, that this is 2. Now again we check with this value. Now this value again, it's 0, and it's the same as this one, so we ignore it. We don't need to do anything. Now again we check with this value. So this value is actually 2. Now with this 2, if we put down this equation, so 2 minus 0, this is not equal to 1, which means that this 2 and 0 are not part of the common subsequence. If they are not part of the common subsequence, we check that now we can't update this current anymore. So we check between the current and longest common subsequence we have so far, and the current is actually greater, which means we will update the longest consecutive subsequence to 2 as well. And now current, we will put it back to 1, because we will repeat our search again. Now we are at this position 3. So 3 and 2 are not same, and 3 minus 2 is actually 1, which is true, which means we update our current. So current would become 2. Now we are at this 4. Again 4 minus 3 is equal to 1. So again we update our current to 3. Again we are at this 5. So again we need to update our current. So current would be updated to 4, because all of these values 2, 3, 4, 5, they are in a common subsequence. Now we are at the 7. So 7 minus 5, they are not equal to 1, which means we can't update the current. So we will need to reset the value of the current. So before resetting the value of the current, we are also going to check that whether the longest common subsequence needs to update, and this needs to be updated to value 4, because this one was 4 before, because of these 4 values. And now we can set this value to 1 again at this position 7. And now we are at this position 200. So 200 and 7, they don't have any correlation, so we can't do anything about it. And in the end, at the end of the loop, we are simply going to return whatever the longest common subsequence or current subsequence, whatever the maximum value we have found between these two. And in this case, the maximum value we have found is actually 4. So this would be our solution. Now this solution works pretty efficiently, it's pretty neat, and if we see the time complexity, we can complete everything in just one single iteration. So we are only doing n work, but the thing is, the time complexity in this case would be go of n log n, because initially remember that from this given input we will actually have to sort the array as well, and sorting takes n log n time. But overall, if we still compare it with whatever the brute force approach we had, brute force was actually big O of n cube. So this was really bad time complexity, and this is much more and much bigger improvement upon our scenario. Now in the optimal solution, we are actually going to try a couple of things. First thing we are going to do is we are going to create an additional data structure called hash set, and in the hash set we are going to enter all the values that we have found from this array. So suppose we create a hash set something like num set. Now in this hash set we are going to add all of these values. Now because we have our hash set ready, what we are going to do is when we are going to iterate over this hash set, and we are only going to start checking for the longest consecutive subsequence from the elements that could be at the start of the longest common subsequence. And what elements can be start of the longest common subsequence? Well, so if we take this example, we can actually see couple of common subsequences or consecutive subsequence. One consecutive subsequence we can find is 99 and 100, which is at these two positions. And second consecutive subsequence we can find is actually 1, 2, 3 and 4. Now in what we were doing in the brute force is we were checking at every single position that what would be the longest common subsequence we can find. The thing is, we can only find the longest common subsequence from the first element of the start of this consecutive subsequence. Same goes over here, that whatever the subsequence we can find at this value number 100, the subsequence that we can find at value number 99 would always be greater than whatever we can find over here, because this by itself is already a subsequence. So we are going to use this logic. Like over here, if we put this 3, 2, 3, 4, we will only find the consecutive subsequence of length 2. but this 2 3 4 would be 3 would be of length 3, and this 1 2 3 4 would actually be of length 4. So we can only find the maximum consecutive subsequence at the start of the any subsequence, not somewhere in the middle. And the only way to check that whether we are at the start of the subsequence or not is by just checking one very simple condition, that at any point we check that whether the exact value before that value, like one value before the value we currently are at, if that exists, which means that we are not at the start of the common subsequence. Let's take it by an example over here and let's see that what would be our approach. So first of all, we are going to be at this position 100. We are going to check that whether this 100 is a start of any consecutive subsequence or not. So we check that whether in this given num set does the value 99 exist. Now we know that 99 exists. So because 99 exists, 100 cannot be at the start of the common consecutive subsequence. So we are going to ignore this case. We don't have to do anything with this 100. We come up at 99. Now we come up at this 99. We check that whether there exists a value before 99. So 98, does it exist in this num set? 98 does not exist, which means that at 99 we can be at the start of any common consecutive subsequence. So we start a subsequence at 99, and now we will initiate our logic. And in our logic we are simply going to check that from this 99 how many consecutive numbers we can reach. So we are going to check that, okay, 99 by itself is a common subsequence of length 1, so we know that. Now from this 99 we are going to check that can we reach value number 100. So 100 we can reach, and because we are using a hash set, we can do all the operations in constant time, so we are not adding any strain in our time complexity. Now we can find the value 100, so we can reach 100, which means that the whatever the longest common subsequence that longest consecutive subsequence we found, we will increase its value to 2. Now again we will try to see that whether we can find 101. Like 101 does not exist, which means we would break out of over here, and the longest common subsequence we have found up until this point is actually of length 2. Again we are going to repeat the same process. So now we are at this position 4. We check that whether 3 exists in this set or not. So 3 exists, which means we ignore this 4. Now again we are at 200, so we check that whether 199 exists. So 199 does not exist, which means 200 can be start of the any consecutive subsequence. So we again check that whether 201 exists, but 201 does not exist in this given example, so we ignore this 200 as well, because the longest consecutive subsequence we find at this value number 200 is always going to be 1, and we already have a value that is greater than 1. Again we check at this position 1 that can 1 be start of any consecutive subsequence. So we check that whether the 1 minus 1, so we check whether 0 exists in this example or not. 0 does not exist, which means 1 can be start. So now we set our current subsequence to value number 1, and now we check that from this value 1 how many other values we can reach to. So first we check that can we reach the value number 2. Yes, we can reach value number 2 because 2 already exists. So we update whatever the current subsequence we can find to 2. Now from this 2 we check can we reach 3. Again we can reach 3, so we will update the current value to 3. Again we check that whether from this 3 can we reach 4, and yes, we can reach 4 as well. So again we will update the value of our 4 value of the current subsequence to 4, and from 4 we check whether we can reach 5. So 5 we can't reach, which means we are at least able to reach this 4. So we are able to see that the current the longest current subsequence we have found is 4, and previous value was 2. So we will update this, so this will become 4. And now again we are going to check the same thing for this value number 2, so that for value number 2 does 1 exist, and 1 exists, so we will ignore this. Again we check for 3, does 2 exist? 2 also exists, which means we are going to ignore this 3. And now since we have reached the end of this hash set, so we are going to reach whatever we found in the as the longest consecutive subsequence, and this would be our answer. Now if we calculate the time complexity would actually be big O of n in this case, because we are only iterating over the entire input just once through this hash set. So this is a very efficient time complexity. And if we see the space complexity, The space complexity is actually big of n because we will have to create this additional numerical set, and we are going to store n memory for that. And let's see the coding. I will be showing the hash set solution in this code, but I'm going to post both the codes in the comments so you can check it out from there. So first of all, we are going to check that whether we are given an empty list or not. If that's not the case, first of all, we are going to create a hash set. We are going to name it num set. Now we'll run a loop across the given input, and we are going to store all the values to our hash set. This is going to do two things. It's going to eliminate all the duplicates values, and it will only add unique entries in the hash set, because hash set has a property that does not allow us it to store duplicate values. Now we are going to create a parameter to store the longest subsequence, and we are going to initialize it with value 1. Now we are going to run a for loop across the given num set. So initially we are going to check that whether we are starting from the middle of any longest consecutive subsequence. If that's the case, we are going to ignore that number. So if this condition is true, we are going to continue and go to next element in the loop. If this is not the case, we are first of all going to mark the number we are at as current number, because this is the beginning of any longest consecutive subsequence. We are also going to create another parameter called current sub that is going to take care of the current maximum consecutive subsequence we can find, and we are going to initialize it to 1. And now we are going to put a condition that while our hash set contains the current number plus 1, while this condition is true, we are going to increase the number, and we are also going to increase our current subsequence. And after this loop ends, we need to check that whether we have found the longest common subsequence or not. So once this loop ends, we should have our answer in the longest sub variable, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working. Let's try to submit the code. And seems like our solution works pretty well, and it is faster than a lot of other solutions. I will also post the sorting algorithm solution as well, so you can check it out from the comments.